Good morning. How y'all doing? I hope that everybody had a good night's rest and is ready to get going on day 2 of the conference. My name is Russell Mirabelli with Bottle Rocket Studios, and I'm talking to you this morning about better core animation with Swift Playgrounds. Now, it's kind of an ambiguous title. Kind of got three words in here that I want to talk about how we're going to be talking about this stuff. We're going to be talking about doing some Swift Playground-based development this morning. That is to say, starting off in Playgrounds and working there to escape from the tyranny of the edit, compile, run cycle. There's a lot of stuff in CoreAnimation that's really great that we lose out on because we don't get a chance to iterate because of the cost of edit, compile, run. So we're going to be using Playgrounds to explore some of these. We're going to be visiting some parts of CoreAnimation that you may have forgotten about or may have been too daunting before. But most of all, we're going to be having fun. Get ready to churn through some battery and type along. You're not going to get much out of this presentation if you're not doing that. For the most part, the source is going to be on the left, and the playground output is going to be on the right of these screens. All of our playgrounds this morning are going to start off with the same thing. So, start up a new playground, and let's get going. Import UI kit, that's already there, and import playground support. Playground support is what allows us to do all kinds of the fun stuff in Playgrounds.
Are you going to use Swift 3 or Swift 2?
I'm using Swift 3, although there are very few differences in CoreAnimation between Swift 2 and Swift 3. As a matter of fact, some of my samples came directly from one to the other with node conversions. Create a view, you know how to do that, and set the background color. View.background color equals, and then start typing the word color literal. If you haven't done this yet, it's a really great new thing in Swift Playgrounds that came in about 2.2, where you can just use a color picker for any color that you might want to use. That saves us from typing UI color or color width, RGB. And then set the current view, live view equals view. And then if you have the assistant editor open in your playground, the double rings, you're going to see that gray square. Nothing very interesting yet, sorry. We'll get there. So you'll notice that the starting point for the first thing that we're going to work on is the exact same as what we did before. Let view, create a view. We're actually going to, this is the starting point for all of our presentations. Then I used an image literal. Hopefully you have a couple of PNGs on your system. I didn't set one up for you to use, but you can just drag, if you didn't know, you can just drag PNGs into your playground now. So you see let clownfish equals, and then an image literal. That comes just from dragging straight from your desktop or other document location into the Swift Playground. And then we're going to create an image layer, which is just a standard CA layer, nothing fancy. All CoreAnimation has to do with layer work. So, image layer frame, we're going to set that to be the same as the views frame. Contents equals clownfish.cg image, and contents gravity equals CA gravity center. Now, this is one of those parts that we may forget. The contents gravity, that's kind of analogous to when you're working in UI views and you're setting the view mode. When you're working in layers, it's gravity. Now, while you're catching up, it's worth mentioning why are we doing this in CoreAnimation instead? Because this is, frankly, something you could do very, very easily with standard UI views. Well, in general, when you're working with CoreAnimation, you can get better performance than you can with UI view animation. Okay? And there are certain features that are going to be only available via CoreAnimation. Okay, now we're going to just add that sublayer. You can see the clownfish there. And we're going to set up a few colors. Okay? In here, I'm using the UI color constants. This is the new Swift 3 syntax for uicolor.clear.cg color, and then adding some alpha components. Okay? And again, we're setting up a vignette. And a vignette is just a small gradient area at the bottom of a photograph so that whatever text you put over the photograph is actually legible. Okay? Don't worry too much about getting the full array of colors, just as long as you've got a couple there, that everything is cool. And then we're going to add the gradient to the main image. We create a gradient layer, CA gradient layer. Okay? Again, we're not animating anything yet, we'll get there. Set the gradients frame to the view frame, the colors equal to the color array that you gave it, and a couple locations to push the gradient towards the bottom. And then we add the gradient sublayer. This is all fairly straightforward stuff. But the nice thing is, now that you're working in a Swift playground, you can actually move quickly and experiment with those locations in a way that was really kind of constrained when you had to deal with a 1-minute turnaround for an edit compile run. Or you had to manually hook up lots of control points into your app and then remove them later. And then lastly, we'll add some attribution text just to throw up a text layer. CA text layer is the straightforward way to add text in a layer. Now, the only thing that I'll caution you about this is when you use a CA text layer, you don't have any accessibility. Yes? I can go a little bit slower, but I've got a lot to get through. So if you do find yourself falling behind, rest assured that within the next 2 minutes, we're going to be throwing it all the way in. And all of this will be available on the slides Slack channel. Anyway, as I said, when you use CA text layer, you don't get any accessibility, and this is pretty important. So be sure that your content doesn't need any accessibility. It's going to be skipped by the screen reader. All right, but that's boring. We're done with that. From here on out, instead of text or actual pictures, we're going to use emoji. And the reason we're going to use emoji is just because it's a fast way for you to have graphics to use when you're playing around in a playground. I don't necessarily advocate it for real-world development, but it works great for playing around. You'll notice I said we were going to throw it all the way. We're going to throw it all the way and start over with a new project. You can either create a new playground and do not feel obligated to follow my colors. They are chosen completely at random. The emoji do give us a lot of shortcuts though, because we can create a text layer, set the frame, font size, set an alignment mode to the center. And you'll notice that we're able to quickly throw a graphic on the screen. So we're going to take advantage of this quite a bit as we go through the rest of our examples. One of the important things to note is that on the text layer, you do have a font size property. Even if you pass in a font that you've created, a UI font that you've created with a size associated, CA text layer ignores that size and instead uses its own font size property. Okay, let's make it move. We can. We'll start off with a clean slate, and what we're going to do is we're going to take what we did and we're going to modify it a little bit. You can actually just modify it because we already have by changing its frame a little bit. Well, we're going to inset that frame, maybe reduce the size of it, and set its background color to light gray. So we actually get something that looks like an icon, because we're going to get things moving now. Use a corner radius like you already know how to do, and add that sublayer. Now we're going to add a 3D transform to what we've already got. Okay? We're going to create a CA basic animation. A CA basic animation just means I'm going to modify a property with the key path that you've given me. Okay? Nothing more than that. We'll set it to be a tenth of a second long animation. And we're going to have it animate from a 3D rotation to another 3D rotation. Okay. This, I guess, bears a little bit of time. All rotations in layers are done in 3D space. The layer space is a three-dimensionally organized space of two-dimensional layers. Okay? And so when we have a 3D transform, we can transform by scale, by translation, or rotation. And we're going to use rotation more than anything else here. And you'll notice that we're giving it a value of negative cgfloat.pi. Okay, that's the new language for pi being moved into the type in Swift, in the part version of Swift. Negative cgfloat.pi times 100. And then what we're telling it with the 001 is apply that value in the Z transform. There's three transforms you have available, X, Y, and Z. X will rotate around a horizontal plane. Y is going to rotate around a vertical. And Z is going to rotate around a line that comes out of your screen. Okay? And then we set the animation to auto-reverse and make it repeat a huge number of times, theoretically infinite. And then add the animation. And then it wiggles. Well, that's fun. Let's make it a little bit smaller by just changing the font size in the frame. Here's where we've got quickly, you've got available to choose your animation because we're playing around. Okay. All right. So that's a very basic rotation animation. Now, another important type of layer that we have that we can work with are shape layers. Okay? And shape layers basically contain a Bezier path that will be drawn as part of its rendering. So we're going to create a view, and we're going to create a shape layer that has the same frame as our base view, and then we'll add that as a sublayer. And there's nothing to see once you've done that. Now we're going to create a CG path and add that to the shape. One of the easiest shapes that you can create is an ellipse. Now it's possible, of course, to draw a circle by creating a rectangle and using corner radius to slam it around. That is a possible way to do it, but you can get a better looking circle if you aren't afraid of the ellipse. And so we just set a frame for the ellipse with no particular transform and assign that path to the shape layer. Tell it to fill in white, and we're done. And we can animate, let's say, the opacity. That's another one of the fields that we can easily animate using CoreAnimation. So we create another basic animation for the key path of opacity. Okay, give it a short duration, 2 seconds. Repeat float.infinity. It's another way of saying huge. Go from 1 to 0.3, have it auto-reverse, repeat. And it looks like I doubled the repeat count. How about it? And then just add that animation. And the nice thing is, again, because you're working in a playground, you can experiment with these to get the kind of look that is right for your app. But that's not interesting enough. So how about we animate the shape also? You'll notice that instead of just directly setting the path to the shape layer's path, I created a separate path variable. Well, that's so that I could have a path 2, which creates an inset ellipse. And then I animate on the key path of path. And I give it a duration, repeat count, and so on. Now the interesting thing is I've got a different duration for the shape change than the opacity, and because they're acyclic, it provides a little bit more interest in the animation. It's still not all that great. You'll never win any Academy Awards for animating a circle into an ellipse, but it's a very easy thing to do. But that's not the only way to create paths. Okay. Another really cool way to create paths is again, back to fonts. So if we start up from scratch again. This one you may not want to type along with because it's really boring. We actually create a function called path from a string that returns a Bezier path. And this is a simple way of extracting the path information from the glyph for the character in the font. Okay, so you do have to go through a bit of extraction work to get that data. Okay, we use CoreText font to get the glyphs from the characters, and we just return a Bezier path based upon CoreText's path for glyph. And again, this is one that won't kill you to not keep up with. That is a lot of trouble to go through to render a single character, because you would not use this to render a single character. But path is animatable, again. So you can have it animate between two letters. You could do this quite a bit. It gets some funkiness because if you don't have the same number of control points in each Bezier path, things can get a little bit weird. Okay? And also you'll see at the end of this, layer.path equals our path. Anytime that you're running a core animation, immediately after you've set the animation, set the value of the layer to that final value, and that'll make the value stick at the end of the animation. Again, we've got something moving now. Now, we've been doing a lot of transforms, and we're always making 3D transforms, but I'm not seeing a whole lot of 3 dimensions. I'm seeing a whole lot of 2 dimensions. So let's see what we can do about this. Okay, we're gonna set ourselves up with a clean playground. And we're going to create a card that we're going to flip. Okay? So the card is very straightforward. It's just like we used before. We just create a text layer, set its background and color, give it a corner radius, put a bunny on it, make sure it's centered, and then add that sublayer. And this time, we're going to rotate this card around the y-axis. Okay? So animation is going to be on the CA basic animation on the key path transform. 5 seconds. Okay. A from value of a CA transform 3D, make 3D rotation from -pi to 0. Okay. That's your from and your to values. Please notice that you have to pass those in as values of CA transform 3Ds. And you just repeat that forever. And then, well, it sort of spins. Yeah, that's not very 3D. In order for that to look actually 3D, the trick is you have to set a subtransform on the host layer, on the parent layer of that animation. And when you do, then you'll get the actual 3D effect that you were hoping for. This is one of the things that I see most commonly as people try to bring 3D into projects, is that you're missing the opportunity to set up the frustum properly. Okay, you set up the transform by creating an identity transform and set the M34 to an appropriate value for your eye position. If y'all are interested, next year I would be happy to talk about 3D math for core animation, but going any deeper than just saying set the M34 to an appropriately small value is as far as we're going to go today. Okay, but that is the difference. You would not believe the number of times that I've seen people miss this step when they're trying to do 3D graphics. And this is where playgrounds really help you out. Because if you're working in your traditional edit, compile, run cycle, you don't have time to get this right. And so you give up. Or at least that's what I've seen happen. Okay. But I want to talk about pi. Why are we always transforming in radians? Why can't we use degrees? I understand degrees. I had a protractor when I was growing up, and it read in degrees, not radians. When I talk to an artist, they talk in degrees, not radians. I don't have any problems with radians, but when I'm talking to normal humans, radians become a problem. So why can't we just use degrees? Well, this is something we got in the new version of Core Foundation. We got the measurement foundation type. Okay, now we've got a text layer, the string, blah blah blah. You know how you've seen all that. Now, rotation in degrees is a measurement with a value of 45 in the unit domain of unit angle degrees. In other words, 45 is no longer hanging around in your code as an arbitrary number. It is a number with context. Okay, that is what's great about measurement is it's going to add context to the numbers in your code. If you haven't had a chance yet to work with measurements, it's a very nice way to make sure that your code makes sense. Anyway, here we can just have measurement perform that conversion for us by having rotation in degrees, rotation, turning to rotation in radians by saying rotation in degrees converted to dot radians. Okay, you get the same thing for any of the domains that measurements will take care of for you. And then we set the transform using rotation in radians along the z-axis again in setting the transform. And you can use those to animate, of course, because it's all the same. So you can set a from value and a to value by creating your transforms in line, measurement of 10 degrees converted to radians to negative 10 degrees converted to radians. And then we do the same thing we've done for all of our animations. Set up a duration, repeat count, auto reverse, and then add it to the layer. Take the layer and add the animation. It's kind of silly to just rock it back and forth, so we'll go ahead and set up a basic animation on position.x, and it'll swim across the screen. Okay. That's all cute. How about something practical? How about something I can actually put in an app? Because nobody's going to make a virtual aquarium in 2016 using this stuff. So how about something practical? How about a custom spinner for our app? Okay. Well, that's something practical. So it's something I get asked for on a very regular basis. So let's create a canvas. And I made a slightly larger canvas this time, 600 by 600. Whatever works for you. Same code as always. And then we're going to create an image that we're going to rotate. Okay? We're going to create a text layer, set a font size, a frame, and a position. Okay. Again, the reason why I've asked you to type along is because it's very easy to get in the habit of these, but I understand if we're moving too fast. So. But again, I'll have all of this available for you on the Slack channel. And then let's add an opacity animation to that layer. Again, nothing we haven't seen before. We create a basic animation on opacity from 1 to 0. Have it repeated a huge number of times, but don't have it auto reverse. It's just going to pop on, fade out, pop on, fade out. And then we're going to use the replicator layer. If you haven't used the replicator layer, the replicator layer takes a layer, and then it will apply changes to it, the number of instance times, the instant counts times you tell it to. So what we do is we pass in a single guitar layer, and then the replicator will give us 10 of them, with their animations running 1/10 of a second apart from each other, each of them transformed by pi over 5 And magically, that when you do that 2 times, it'll become a full circle. Okay? And so then you have this custom spinner. Very easy, very, very inexpensive. Okay, if you were to do this with UI view animations, it would tend to get expensive on the CPU. This is incredibly cheap. It all runs on the GPU. Okay? And because we've got it in a playground, it's very easy for us to iterate to get the exact right spinner that we want. So that's kind of cool. Now for some real fun. Particles. I love particles. A lot of times when we think about throwing particles into a project, we go to Sprite Kit because they've got a nice editor for us. And because it's very difficult to set up particles, or it seems to be very difficult to set up particles directly in a layer. But that's not really the case. It's actually very, very easy to set up particles. So we're going to create a canvas, et cetera, et cetera, et cetera. And now we're going to create an image using a text layer. Okay? So we're going to create a text layer, make it small and make it a heart. And then we're going to take that layer and get its CG image. Okay? The CG image that backs that text layer. And this is new in iOS 10. This is before you would use some methods to get the current context. With this, the UI image graphics renderer, we actually set up a block that we're going to render from. And when the block is invoked, it will give us the appropriate context. It's a little bit easier way to set things up. It does take less code, and it's a lot less error prone. Then we're going to create an emitter. So give it a frame and throw it into the big bucket layer by setting it as a sublayer layer. And then what an emitter uses to spew out particles are cells. Okay. So we're going to create one cell, and that will be the template for the particle system. Its contents will be the CG image of the image that we loaded. And we're going to give it some parameters like a birth rate of 2 and a speed of 10 and a lifetime of, it's going to stick around about 10 seconds. And that's kind of enough setup. We just set the cells as an array of that one cell item and put the emitter in the center of its layer, give it a shape of a sphere, and give it a size and a render mode of oldest first, although you could do newest first, all depending on what painter algorithm you were looking for. But that pops a lot. That was kind of gross for a particle effect. And again, this is where working a playground first really gets you that benefit. Because now we can tweak all these parameters nice and easy, and we can have it pop a little bit less. But that was only one image. So in the playground, you can refactor really easily by tossing all of our cell creations into a method create cell that took a string and return a cell. I wouldn't ever actually write this code, but in a playground, I'm happy to write this code. And then we can always refactor out of the playground. But this is just wrapping what we already had. And then we can create lots of those emitters. Okay? Because the emitter cells don't have to work with one kind of cell. In fact, we could create a method that creates that array of cells out of a full-length string by using a map transform on the characters out of the string. So that when we create a cell array, we actually get lots of different particle types. And that's starting to look more usable, and realize that it's going to be running very slowly because it's running in the simulator, and anything graphical is very slow in the simulator. On hardware, this runs at 60 hertz without using any CPU time. This is all on the GPU. So that was really cool. One last thing I wanted to do. I really liked the WWDC logo video this year. It was an apple that was made up of lots of letters and symbols, programming symbols, and they flickered in and out. I thought that was really cool. So I kind of wanted to duplicate that. I wanted to create that for a web page that I was writing. And so I started off in a playground to create an image like that. And so I started off by importing playground support and GameKit, because we're going to use GameKit for some randomization. Create a black view, and here I'm creating it as 256 by 256. The reason why is because this actually ends up being fairly time-consuming, and because I didn't want to take all of your time this morning if you tried to run this. So in reality, I set this up to be a 2048 by, I don't remember how tall I set it to be, but it took a good long time to run. And then I created a method that returned a character layer when it was given a character. A reminder in there that the font size doesn't come from the font, that the layer itself specifies the font. And then layer string equals string of the character that was sent in. Okay, so then what we're going to do is make a series of individual random character layers. Okay, now we're doing this by setting up a random number generator and an array of colors, and those are all just color literals for UI colors, using just by typing the words color literal, and then you get 9 values or so. And then random character layer, where I just take in a string and return a font, and I only look at the first character in that string, and create a single character layer from it. And then I give that layer a foreground color based on the array and a random value from that array. And then I just fill in the view using an ugly for loop. I set up the character set. Remember, you have to escape out your backslashes and quotes. Give it a height, and have it loop through until it fills out your canvas with individual character layers. Each time that you insert one, insert it at the height and width offset. And then you get a nice little field of characters. And that's kind of nice. It's kind of useful the way that it is. And so if you wanted to save that image out, if you wanted to get that out of your playground, you got a couple options. You can, of course, take a screenshot, but that's not very cool, and it only works for images. What if you wanted to save other data out of your playground? Well, all you need to do is create in your documents directory a folder named shared playground data. And once you've got that shared playground data directory, then you can use playground shared directory and then append a path component to it, and you'll get a URL that you can use to save to. This is sandboxed and safe. Okay? And then what we can do is we set up an image renderer, okay, the iOS 10 style image renderer, and have it get the JPEG data. And again, that gives us our context inside the callback, and all we have to do is call render on our layer into that context. And now we're able to save off our work from the playground. This is not something that I only use for graphics, though. I use this a lot if I'm trying to generate some runtime data, if I want to just build out a couple of objects and then dump them into adjacent dictionary. It's just as easy to do it in the Swift playground as anywhere else. And then you've got your shared directory that you can use. But I like the apple shape, not just the field of characters. So how do we get there? Well, we can apply a mask layer to our host layer. Okay? That's really easy. We set up a mask layer, and we get a frame, and set the mask layer to be clear as a background color, because the mask is going to use wherever the alpha is 0, it won't draw anything. Wherever the alpha is 1, it will draw something in. Everywhere else, it will do something in between. And then we simply add a single character used in that text layer, add the sublayer, and set the host layer's mask to our new mask layer, and then we get that nice. It's kind of hard to tell on that screen, but it's the letters in that shape. So that's cool, but it's not animated. So one nice thing that you can do that I didn't have the ability to do when I first experimented with this by building it out using just plain strings was the ability to swap out layers at runtime. So we create an object, we create a class that can update a CA layer. We'll have the initializer pass in the layer and the string and the font so that it doesn't have to know too much about the outside world. And then it'll have a function update that will go through the sublayers, remove one, grab its frame, set it to a new character sublayer, and then add the new one and throw away the old one. And then we can use that new class on screen refreshes. And the way that we do this is we tie into the CA display link. Okay? In other words, every time that the frame flips, this method gets called. That is the correct way to handle keeping yourself at 60 hertz. You don't want to set up a timer that fires every 60th of a second or every 0.016. Any of that stuff, those are not reliable. The way that CA display link is. If you want to do anything more precise than the frame refresh, you'd have to find another way. Right? But display link is the proper way to work on it, frame refresh. And then you can get that nice little animation that we saw from the WWDC logo. So these are just a couple of the things that I've been doing lately in a way to get myself out of the drudgery of the edit, compile, run cycle, and by getting more ingrained back with the basics of CoreAnimation in a way where I can take advantage of their power without having to worry about the complexities because I've abstracted away that cost of about a minute per edit that you make. So that's all that I have for you this morning. Thanks a lot for your time.